Hello everyone, welcome to this video on control charts. Today we will discuss about control charts, why we need them, how they can help us, and their different types. Studying control charts is also popularly known as statistical process control. Control charts indicate how a process changes over time. Let's have a look at a sample control chart. It has a central line for an average, an upper control limit, and a lower control limit. These limits come from our process performance data, that is historical data. The distance between the average and the limits on either side of the average is divided into 1 sigma and 2 sigma units, where sigma is the standard deviation, which we have talked about in our video 1.2. If we plot our current process data on a control chart, it would let us know whether our process variation is consistent or unpredictable, that is in control or out of control. If you are interested in statistics or pursuing a career in quality management, you would agree that the whole world talks about control charts. Why do we need a control chart? There are several important things that it tells us. It helps us to find and correct problems as they occur. It can help us to predict the range of outcomes. Tells us whether the process is in statistical control, gives insight into special and common cause variation. Let me tell you here that common cause variation is inherent variation in a process, and special cause variation has assignable causes. We need to analyze and find ways to minimize them or eliminate them. If we are doing a quality improvement project, control charts helps us to decide if we just want to prevent specific problems or make certain fundamental changes to the process. So now we have seen how a control chart looks like, what it can do for us, and if you have already started thinking as to how it is going to tell us all of these, let me assure you that you are on the right track. A control chart interacts with us through signals. Well, not the ones from an alien planet. It's from the chart itself. It's from the data itself. Let's see how. I'm quickly pulling up the sample control chart for you here. Important to know is that a control chart indicates what we call as out of control signals, which means certain data points which statistically seem to be going haywire. There are a good number of rules which lets you decide if a process is in statistical control or not. Broadly, we will talk about 4 important rules here. A single point outside the control limits, which means a data point which is probably outside the UCL or the LCL. Let's look at the adjacent chart and we will find it here. It's a little above the UCL. Next, 2 out of 3 successive points are on the same side of the center line and farther than 2 sigma from it. Here it is on the chart. 4 out of 5 successive points are on the same side of the center line and farther than 1 sigma from it. Let's look at the chart. Here we go. Here it is. A run of 8 in a row. A run of 8 in a row are on the same side of the center line, or 10 data points out of 11, 12 data points out of 14, or 16 data points out of 20. For your knowledge, a run is a series of increasing or decreasing values, and the number of data points in the run is the length of the run. I must tell you at this point that there are different types of control charts, and based on the data we have, we need to decide which control chart best fits our data. Let's look at a decision tree quickly. It's very interesting. It all starts with data types. So now you know why our first video was on data types in statistics, right? Well, data could be continuous or discrete, as you are aware of it. For continuous data, we check the subgroup size. A subgroup is a group of units that are created under the same set of conditions. It represents the process as a whole. Subgroup size could be 1, 2 to 5, or 5 and more. If it is 1, we use an individuals and moving range chart, IMR chart. For 2 to 5, we use X bar and range chart, that is X bar R chart. And for 5 or more, we use a X bar and standard deviation chart, which is also known as X bar S chart. Now looking towards the left, if data is discrete, we check if we are dealing with defectives or defects. As you know, defectives is a unit and defect is an opportunity. For defectives, we check if sample size is constant. If yes, then we use an NP chart. If no, we go for a P chart. For defects, we again check if sample size is constant. If yes, we use a C chart, and if no, we go for a U chart. This decision tree is by far the most important item and comes in very handy when you are checking for statistical process control. I would advise that you print this visual map in your memory. Before we end today's discussion on control charts, let me tell you that our forthcoming videos will cover each of these control charts for you to understand its application and benefits. I hope you have fallen in love with control charts by now, and trust me, it's going to get better. I thank you so much for watching this video. Please share your comments or get in touch with me on LinkedIn. And finally, please do subscribe to this channel to stay updated on more interesting topics to come. And as I've already said, you can send me your requests for any specific topic that comes to your mind. Thank you once again and have an awesome time.